Well, I wanted to give more problems for you to look at in this section than normal because really the whole idea of this is just problem solving. Can you use integration by parts? Can you use it with other methods? Can you differentiate, pun unintended, between the different methods? And so we're going to do 2 videos with just more problems. This video is going to try to be mostly the simpler problems, and the next video is going to be maybe the more advanced problems, just to give you some more exposure because this is an important method and really brings together a lot of material. We'll start with question 2 from the homework. Choose carefully which expression is u. For each of the following problems, use our guidelines to choose u. The book, it doesn't want us to evaluate the integral. The book also has like a Liane method or something. It has a mnemonic. What mnemonic did they use? Maybe I didn't write it down. There's something in the book for choosing which is which. I don't remember what it is. Something like Liane or something. I don't know. But I think I like the way that I presented it. But if you struggle with finding which is u and which is dv, then look at that book's little mnemonic, all capital letters. But we're curious about the integral of x cubed, ln of x. We want one of these to differentiate and one of these to integrate. That's how we're choosing our u and dv. So this, we could differentiate it or integrate it. They're both fine. Differentiating it is easier. Here, we don't want to integrate this. We sort of could with a natural log of absolute value of weird stuff, but we don't want to integrate this. So let's differentiate this and have it be our u and have this be our dv. And that will work for this one. That's the whole problem. That's all they want you to do. Next one, number 9. Also, again, I please highly, highly recommend before you watch this video, try these problems that I'm doing. Okay, pause the video, try the problem, and then continue with the video. Don't just watch it. Highly, highly recommend. You get a lot more value if you struggle with it first. Find an integral using the simplest method. Not everything is going to require integration by parts here. Integral of arctan. No, let's not do this one. We did this one basically in the last video. Let's do the integral of x cosine of x to 8. Okay, so we need a u. We need a dv. Either one of these is easy to integrate. Either one of these is easy to differentiate. But if we differentiate the x, it goes away. So that's even nicer. That's what we're going to prefer here. And if we do that, we let u be x, dv be cosine of x dx. The antiderivative of cosine is sine, and the derivative of x is just 1. The integration by parts gives us uv minus the integral of v du. And the second integral is no problem. We'll get x sine of x. Antiderivative of sine is negative cosine. The negatives cancel. We get this our answer. Should be able to check by taking the derivative and showing that the derivative of this is the integrand for number 8. All right, let's do the next one. Jumping all the way to number 40. Compute the definite integrals and use a graphing utility to check your answer. Integral from 0 to 1 of e to the square root of x dx. So they nicely tell you to let u be the square root of x. Now this is a sort of a weird example because it's not obvious that this is going to be helpful at all. Well, let's see what happens when we do what they want. The du is going to be 1 over 2 root x dx, which we don't have. So we either need to put it there or solve for dx. It's your choice. Remember, one of the ways that we did u substitutions was actually to solve for dx instead of du. Because now what do we get? We get the integral. Well, let's change the limits. Right? If x is equal to 0, then u is the square root of 0. If x is 1, u is the square root of 1. Oh, that's nice. The limits don't change. Now e to the square root of x becomes e to the u, and dx becomes 2 square root of x du. We can't integrate this yet because we need everything, we need all the x's to be gone. The 2 can come out in front. What happens with the square root of x? Square root of x is just u. We get u e to the u, du like so. And then we can use integration by parts. So this is easy to differentiate. We can call it u2 or w, whatever you want. This is easy to integrate. We'll let this be dv. So u2 is just u. That's a little confusing. Let's call it w instead. All right. W is u. dw is du. dv is e to the u du. So v is just its antiderivative, e to the u. So we get, remember, the whole integral is integration by parts. So the whole integral and whole integration by parts gets that 2 in front. So we get w times v, which is u e to the u, minus the integral of v dw, which is e to the u du. These are definite integrals. So this is from 0 to 1, and this is from 0 to 1. And we can keep things in terms of u. So when we do that, we get 2 times, this becomes 1 times e to the 1, minus 0 times e to the 0, minus the antiderivative from 0 to 1. Becomes e minus 0 minus e to the 1 plus the negatives cancel, e to the 0. I feel like I'm off by a negative. I feel like I'm very surprised if this equals 1. I think I made a mistake, but luckily we're checking our answers anyway. I got that the answer was 2. Is that right? I feel like I made a oopsie. The integral from 0 to 1 of, what was our, I don't remember our problem. E to the square root of x. It is 2. Great. Next problem. 48. Derive the following formulas using the techniques of integration by parts. Assume that n is a positive integer. These are called reduction formulas because the exponent has been reduced by 1. The second integral is easier than the first integral because n is a positive integer. So we want to use integration by parts to make the integral of x to the n e to the x easier. And we've done this. We've done this when n is 1, and we've done this when n is 2. When n was equal to 1, we did integration by parts once. When n was 2, we did integration by parts twice. Well, this is a reduction formula because we can use it n times to evaluate the integral. October. Don't do that. Don't play with that. That's not for fun. So, just like before, this will be our u. And this will be our dv. U is x to the n. Its derivative is just the power rule. Bring down an exponent, subtract an exponent. Remember, this only works if n is not negative 1. That would be a natural log. Sorry, that's integration. This works all the time. Yeah. dv is e to the x dx. So v is just e to the x. We get u times v, which is x to the n, e to the x, minus the integral of v du, is e to the x times n, x to the n minus 1 dx. And now we just clean it up. Factor out the n, it's just a constant. And then we usually write the polynomial, or the monomial in this case, term first. And we get this. That's exactly what they wanted us to show, right? They wanted to show that it was x to the n, e to the x. Got that? Minus n, integral, x to the n minus 1, e to the x dx. That's all it wanted us to show. And then we could do this n minus 1 more times, if n were a positive integer, which it is, and eventually evaluate this integral. But we're not going to. 53, last one for this video, and then we got more in the next homework problems video. State whether you would use integration by parts to evaluate the integral. If so, identify your u and dv. If not, describe the technique without actually doing the problem. So it's not asking us to actually do these, just talk about them. So 53 is the integral of ln squared of x over x dx. Okay, so would you use integration by parts? If you did use integration by parts, remember that this would be ln squared of x times 1 over x dx. Multiplication. We need multiplication if we're using integration by parts. One of these could be u, one of these could be dv. Well, we don't want to integrate this. We could differentiate it, but it'd be kind of messy. Integration by parts might work. Get antiderivative of this, we get more natural logs. Probably not good. Probably integration by parts is not going to be nice either way. But a u substitution could be. Why? Because if u is ln of x, du is 1 over x dx. That'd give us a u squared and a du. Yeah, a u substitution would work. So this in red is all I would need for an answer for this sort of question. U substitution, that'd be your u, that'd be your du. We'd be good to go. That's all there is for this video. Let me know if you have any questions, and good luck.